Hey folks, let's solve some gravitational potential energy. Gravitational potential energy is the energy that an object has just by being up high. If we let it go, it's going to do a lot of work as it falls down to the ground. In this specific example, we're going to solve the gravitational potential energy of a 20 kilogram anvil that is 5 meters high. If you're not sure what an anvil is, it's those large pieces of metal that a blacksmith would use, or that Wile E. Coyote would drop on the Roadrunner. Now here's the equation that we're going to use. Eg, which is our energy gravitational, is equal to the mass times gravity times the height. Our mass has to be in kilograms. Our height has to be in meters. And g, which is our gravity, is going to equal 9.81 meters per second squared. Our energy is going to be measured in joules. So there's all the units that you're going to have. Sometimes you have to watch these to make sure that your object has been given in kilograms or that your height has been given in meters. If you get grams or centimeters, be watch for things like that. Let's go ahead and fill these in. Our energy gravitational is equal to the mass of our anvil, that's 20, multiplied by gravity, that's 9.81, multiplied by the height of our anvil, that's 5. Great news about this is a plug and chug question. You can just go ahead and put those directly into your calculator, multiply those out, you are going to get 981 joules of energy. So this anvil that is 20 kilograms and 5 meters high has 981 joules of potential energy. That's the energy it could unleash if we were to drop this thing. Let's go ahead and do another example. Alright, so here's a new one. A 20-gram coin is at such a height that it has 50 joules of energy. How high is it? Now, there's a little shenanigan in this question, and I hope you were paying attention to the first one. Because the very first little shenanigan that we have here is that our coin is given in grams, not kilograms. So if you want to convert a 20-gram coin into kilograms, you're going to have to do 20 divided by 1,000. That's the conversion to convert grams into kilograms. And you're going to get 0.02 kilograms. If you forget to do that, you are going to have one powerful little coin at the end. Now that we've converted this into grams and we've been given joules, we're going to try and solve the height. We still use the same equation. Our energy gravitational is equal to mass times gravity times height. And let's fill in what we know. The energy is 50 joules. 50 is equal to the mass of our coin, 0.02. G, that's gravity. We still know that. Nothing has changed. And we're going to multiply that by the height. That's what we don't know. Great news, all we have to do is divide both sides by a 0.02 and a 9.81, and we're going to do the exact same thing to this side, 0.02 and a 9.81, and that's going to rearrange this equation so that h equals 255 meters. Still not real close to the ground, but that's how high you would have to lift a 20-gram coin so that it would have 50 joules of energy. I hope that this was helpful. It's a couple different ways that we can solve gravitational potential energy. The actual calculations themselves, it's a nice little equation, usually plug and chug and can be easily rearranged around. Good luck with working on these. If you have any questions at all, please feel free to leave them in the comments below.